Okay, so last time we talked about templated functions. So what we're going to be doing now is we're going to be talking about how to write a templated class. Really, that's a huge win, right? I mean, being able to write a templated function is kind of cool, but being able to write a templated class is a pretty huge win. It means that we're going to be able to do things like what the standard template library does, right? So in the standard template library, when we defined a vector, we got to say what were the objects, what type were the objects going to be in the vector, right? So we could we write a vector class and it works if the objects are ints, it works if the objects are feet inches objects, whatever. So that's what we're going to be working on, being able to do that. And the way we're going to do that is we are actually going to create our own vector class that has that capability. So it's going to work pretty much exactly the same as at least that portion of the vector class, the standard template library vector class that we looked at, right? It's not going to, of course, be full featured like the STL vector class is, but the client program that I wrote at the beginning of class last time that used the STL vector class, we're going to be able to run that exact same program using my vector class that we're going to create. So let me start by just showing you a version of that class that only works with integers. And then we're going to go through the process of converting that into a class that is templated so it can work with any type of object. So I think let's just, so here's a header file for the my vector class. Let's just look at a couple things that might seem odd. So we're going to have a size type. We talked about that fairly extensively last time. So hopefully that'll make sense. The way we define that is with this standard C++ keyword size_t. That's a type that's defined by C++ that is guaranteed to store the maximum size of a theoretically possible object of any type. So it's a good choice for our size type. Okay, and then we've also got this thing here that you probably haven't seen before called value type. The reason for that is we're going, instead of using int throughout all of our code, we're going to use the word value type instead. And what that means is that later on, if we decide the programmer, the class programmer, if we want to go back in and make it so that this is a my vector of strings instead of a my vector of ints, instead of going through the entire class and changing every occurrence of int into string, we just have to change this one line right here. So you could think of this as being sort of like a constant except for types. Okay, so good question. Type def you haven't seen before. It basically it's basically like an assignment statement, right? You're just saying, okay, from now on, whenever I say value type, what I mean is int, right? And from now on, whenever I say size type, that's just another way of saying std : size_t. That makes sense? And so hopefully it makes sense what I said, that it's sort of like a constant except for types, right? So throughout my code, when I am writing my code, instead of using the word int, when I want to refer to the type of the objects in the vector, I'm going to use the word value type. And so then it's going to be really easy if I need to change that later on. Anybody want to ask a question about that? Okay, so the reason we don't use size T directly is that, well, I guess one way of answering that is, well, this is what they do in the standard template library, so we're going to copy that. The other reason, though, is that, so in our, when we're the client, we don't want to have to try to figure out what the class used for their size type, right? Maybe the class uses size underscore T for the size type, but maybe they just used int for the size type, or maybe they used an unsigned int for the size type. So as the client programmer, if we just guess and we use size T, then we don't really know if we're using the correct type that they used in the class. So if we just have this convention of always having a size type in every class, then we always know that we are using the correct type. And then for int, so this is maybe the analogy to constants isn't working here, but let me just try it one more time. Asking why we don't just use int directly is sort of like asking why we don't, like if the array size in a program is 1,000, why don't we just use the literal 1,000 throughout the entire code, right? And so hopefully most of you by now have kind of gotten the idea that, well, it's better to use a constant for that, primarily because it's easier to modify the program if we decide the array size needs to be 10,000 instead, right? Same exact thing here. We're going to use value type instead of int so that later on, if we want to modify this code, it's going to be, we're just going to have to change right here. We're going to change int to whatever we want to change it to instead of having to change it every time throughout the entire program. So, all right, exactly. Yeah. And now let me just clarify one thing about that. Well, let me just say that on size type and value type, it's fairly common to only have sort of a vague idea of what's going on with those and why we're using them when you first see it. And so I'm going to just say that's okay. Just kind of go with it. And often you just sort of become more familiar, more comfortable with it as you see it in use. What was the other thing I was going to say? Oh, so I want to just make sure we distinguish between using a templated class, which makes it so that we can have the objects in our container be of any type. So there's going to be two different techniques for making it so that we can use any type of object in our container. This, what I'm showing you here, makes it so that the programmer who is programming the class can change the type of the objects in the class, right? So if I'm the class programmer and I find out that I don't want a my vector of ints, I want a my vector of strings, I can just change int to string right here and I'm done. Okay. But if I'm the client programmer, I don't have that option, right? So what we're going to be talking about today is templated classes, which is a way for the client programmer to be able to control the type of object that goes in the class. Anyone want to ask a question about that? I wouldn't really say there's a connection between templated classes and using type def. This is just, I guess this is just sort of a new idea that I happen to be introducing at the same time. The reason I'm introducing it at the same time is because the standard template library does it this way. So in one sense, the only reason that I'm even showing you this is because when you use the standard template library, it's nice to understand that this is what's going on inside the classes that you are using. So every time you use a class from the standard template library, you're going to have the option of declaring variables of type size type or value type. So what we're doing with a template is, and I'm going to define it just in terms of what our objective is, because I haven't actually showed it to you anyway, but what a template is it makes it so that you can have one class, and that class could be a vector of ints, or it could be a vector of strings, or it could be a vector of feet inches objects, or it could be a vector of any other type, right? And so in terms of our client program, maybe I can get the code we did last time up here real quick. So notice when we declared a vector, we got to tell it what the objects inside the vector were going to be, right? This is going to be a vector of ints. So we could put string there, we could put feet inches there, whatever. Not sure why I'm stuck on feet inches, but so what we're going to be talking about today is how do we write this class? How do we write a class that makes it so that the client programmer who's using our class can just indicate what type the objects are by putting the type in angle brackets after the name of the class like this. So I showed you how to use a templated class right here. Now I'm going to show you how to actually write your own templated class. So I guess template kind of makes sense as what we call it, right? Because we think of the class as a template. It's not actually a class yet until it's just something we use as a template. And then when we know what the type of the objects are going to be, then the compiler actually creates the class. Okay, so hopefully these data members make sense, right? We're going to have a capacity and we're going to have a size. The M here is just here to remind me as I'm writing the implementation of the class that these are member functions. And then items is going to be of type whatever value type is. In this case, int. Okay. And then you'll remember from last time that we had a size function, a capacity function, and a pushback function. We also had a square brackets operator overloaded. We're not gonna actually do that here. And then the only other thing we have here is the constructor. Let's take a look at that for just a minute. So hopefully you remember about default parameters, right? So I'm just saying my constructor, if I provide two parameters, the first one is, if I provide two arguments, I guess I should say, the first one is going to be the initial size of the vector. And the second one is going to be a value that I use to initialize all of the objects in the vector. Okay, now this syntax may look a little strange, okay, but it's going to be fairly important that you get used to that. That right there is just calling the default constructor for whatever the value type is. And so in other words, what I'm saying here is set in value equal to whatever the default value is for value type. Okay, so in our case right now, value type is int, right? So what that code right there is saying is that let that parameter, let the default value for that parameter be whatever the default value for int is, which is 0. Any questions about that? I know that that may be new. And this is actually calling a constructor, right? And so it's creating an object. We call it an anonymous object because we don't actually give it a name, right? But it's creating an object, and then it's assigning in value to whatever that object is. And if we call a constructor with a primitive type like int, well, C++ just has default constructors for the primitive types that are going to get called. And so if it's int, the default value is going to be 0. Anybody want to ask any questions about that? Okay, that's not, I mean, that's kind of a detail. It's not like super important to the overall concept here, but it's one of those details that's going to come up in the assignment. So if you're not getting this, it's going to cause a problem when you're doing your assignment. You'll see. Okay, I think that's all I want to say about the header file. Let me just take a look here at my notes. Okay, let's take a look at the implementation file here. So most of the functions in the implementation file are pretty basic, right? Here's the constructor. I'm just setting m size equal to n size, and also m capacity equal to n size. So when we first start, the capacity and the size are going to be the same. And then here's where I am creating the dynamic array that is going to be used to store the items in the vector. And then here I just have a for loop initializing each item in the vector to whatever I said the default value for objects in the vector should be. Any questions about the constructor? Okay, this is a fairly common pattern that you should get used to in terms of when you have a class that uses a dynamic array, which is fairly common. When I teach the data structures class, this probably comes up in like maybe a third of the assignments or something, right? So the way that works, if you need a dynamic array as a member function, is you're going to just define a pointer in the class declaration. And then in the constructor is where you're going to actually allocate the memory for that array right here, right? Okay. The size function just returns m size. Skipping this one for a second. The capacity function just returns m capacity. The at function basically just returns item sub I. That part should make sense. I is the parameter. We're just returning that element of the dynamic array. And then I have an assert function here. Can't remember if I think we've used assert, right? Anyway, so assert is just going to say, if this isn't true, then the program is going to just stop, and you're going to get an error message. Okay, so this is just making sure. Remember I mentioned that the at function does range checking, right? So instead of just plowing ahead and trying to access item sub I, we are first going to check and make sure that I is in the appropriate range. Okay, so I'm just taking a look at pushback. And again, I suppose the actual implementation here isn't the key point, but this is a fairly common technique that you're going to see. You're probably going to have to write some code like this when you get to data structure. So it might help to just understand what's going on here. if we didn't have to worry about the dynamic array being full, it would just be 2 lines, right? Whatever the value is that was used as an argument when I called pushback, put it into the dynamic array and increment M size. Done. The problem is if M size is not less than M capacity, that means that we need to make the dynamic array bigger in order to hold the new piece of data. And what we're going to do is we're going to simply double the size of the dynamic array when that happens. This is a detail, so I would skip over that for now and just focus on what's going on down here. Okay, so basically we're saying if the dynamic array is full, then what I'm going to do is I'm going to create, I'm going to allocate a new dynamic array. And so I doubled the size, I doubled M capacity here. I guess I can't skip this. Let me back up a little bit. So here, normally what I want to do if I need to increase the size of the dynamic array is I'm going to double the capacity of the vector. So normally I do this, right? Problem is if the capacity is 0, I can't double it. So instead I make it 1. So all of this is just to say, make the capacity bigger. Then I'm going to allocate memory for the new dynamic array. Then I'm going to copy over the old dynamic array into the new dynamic array. Then I'm going to put the original value that I wanted to insert into the vector into the dynamic array. Increase the size of the dynamic array of the vector, I guess, by 1. Delete the old dynamic array, and then make the items data member point at that new dynamic array that I just created. Okay, so not sure how many of you followed all of that. Probably wouldn't be a bad use of time to actually go through that in excruciating detail, but I don't want to do that unless we get through everything else first, since it's not really the focus today. So I think I'm going to just go ahead and move on. But feel free to let me know if you would like me to go over that some more if we have time at the end or something. Okay, so any questions about the implementation of our myVector class? And again, I think that there's not very much new here, right? Pretty much everything we're doing here is stuff you've seen before. I suppose I haven't technically talked about type def before, so that's sort of new. But the basic idea with this class is that we are starting with something that we already know how to do. And the next step is going to be to convert this into a templated class. Looking at the client just real quick, this is exactly the same as what the client was in the very first example I did last time, except that I'm using my vector class instead of the STL vector, right? So instead of saying vector with int in angle brackets here, I'm just saying my vector. I think everything else is exactly the same. Okay, and then just might as well, oops, that's not what I want to do. Might as well try this out. Client, CPP, and my CPP. Oh, I guess it would help if I was in the right place. And there's our output. Okay. So just sort of a digression for a second here, but I think that all of you are either taking 210 or have already taken 210, right? So most of the stuff I'm doing here should look familiar to you. And so, you know, if you wanted to, you could do all your work in Linux instead of in one of your IDEs. Not that I would recommend that. Okay, so I'm going to take you through a 5-step process of converting this regular not templated class into a templated class. The objective being that we're going to be able to, let me just, I think actually showing you the code that I want to have work is a good starting point. So let me see if I can find that in the lesson here, and we will take a look at it. That's the wrong section. Okay, so here's what the new class is going to look like. Let me just copy that. So here's what our client looks like when we're using a not templated class. When we're using a templated class, a second here. So just to compare, right? Instead of just saying my vector v, I'm going to say my vector int v. And now when we use a templated class, that means there's no longer a such type as my vector. I'm always going to have to say my vector with something next to it. Okay, that's a fairly important point that is easy to miss. So let me say that again. If I'm the client, actually, whether I'm the client or the class programmer, if I'm working with a templated class, there's no longer a such thing as a type called just my vector. Anytime you say my vector, you're also going to have to put angle brackets something after it. So everything else looks pretty much the same, except when I declare something, right? Instead of just my vector, it's going to be my vector int. So our objective for the next half hour or so is to make it so that this code here will work with my vector class. Okay. Any questions about what we're doing there? Anybody unclear on what's going on? Now, ideally, if I would like to have seen some code here that says like string or something like that. But that's not trivial, so I'm not going to provide that. But the idea here is that we could also have in the same client, we could have my vector string v2 and, you know, v2 dot push back hello, something like that, right? See out v2 dot at 0. You need the brackets because we changed the template class. Yes, that's correct. You need the brackets in, well, because we changed to a templated class, but also because I need to tell it what type the objects in the vector are going to be, right? So down here, they're not ints, they're strings. Interesting, it doesn't recognize string. Anyway. Okay, so anyway, these 3 lines of code right here, I just wanted to throw those in to make sure everyone's tracking with the fact that when I finish here, no, because I've got using namespace standard std up here already, so that's not it. So the point here is to be able to use my vector with any type of object in the container. Okay, let's get going. 5-step process. In the lessons, there's actually going to be a step 6, but you can pretty much just ignore step 6. So I'm going to say it's a 5-step process. Okay, step 1, place the template prefix. I'm trying to think if I want to actually type this out someplace. Place the template prefix before the class declaration and before each member function definition that occurs outside the class declaration. Okay, that's step 1. So the template prefix, you may recall, is that template class T, right? So we're going to place it before the class declaration. And we are going to place it before each member function that occurs, each member function definition that occurs outside the class declaration. So better make a copy of that so I don't have to keep typing it. Okay, so that's step 1, done. Let me just throw out right now that one of your assignments for this lab is going to be to, I provide you with a not templated class and you have to convert it to a templated class. So what we're doing right now is exactly what you're going to be doing for one of the 2 parts of this week's lab. Step 2, place a T after each occurrence of the class name that occurs outside the class declaration. Okay. Why don't we have to do that for if the class name occurs inside the class declaration? Well, because we've already said that this class is a template class, and so that's already taken care of. Okay, in our case, the class name doesn't occur inside the class declaration anyway, but just in case it did, you only have to do this for each occurrence of the class name that occurs outside the class declaration. And now here's a subtle point, okay, almost important enough that I would add it to the description of the step, but I don't want to do that. But just keep in mind that this is only when that word is being used as a class name. So here, my vector is being used as a class name, so I put angle brackets T after it. But here, it's not being used as a class name, it's being used as the name of a function. So we don't put the angle brackets T in that case. Okay. And I'll just tell you, as far as I know, and certainly in our class, that's the only instance of seeing the class name there, my vector, and having it not be actually the name of the class is when it's the name of the constructor. So another way of saying what I just said is that always put angle brackets T after each occurrence of the class name, except when it's the name of the constructor. Okay, so let me go ahead and do that. Please tell me if I miss anything, okay? Okay, I think I got everything. Any questions about step 2? Okay, step 3. Replace each occurrence. So we do step 2 in the parameter list as well? Yes. Did I miss one in a parameter list? I guess we just didn't have any. If you're writing a templated class, then I'm not sure if I understand that question. If you're writing a templated class, you're always going to want to have the angle brackets T. The only exception is when it's the name of your constructor. So I think the one exception here is right here, right? I don't have angle brackets T after the word my vector there because that's the name of my constructor. So not sure if I answered all of those questions. Feel free to let me know if I'm still not understanding that. Okay, any other questions or comments about step 2? Okay, so step 3, replace each occurrence of the original type with T. Okay, so if we weren't using a value type, we would have ints all over the place here, right? This would be int, 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 and so on, right? In that case, we would have to go through and find all of the ints and change them to T. The one thing you have to be careful with there is you're only changing int to T if int is representing the type of the object, right? If you have, if you're using int for some other purpose, then you wouldn't want to change that one to a T. So in our case, because we used value type, we only have one occurrence of the word int on all of our code. And so we just change that to T. Okay, any questions about step 3? Okay. Step 4 is a little more subtle. the problem here, before I tell you step 4, let me tell you the problem that we are solving with it. So if we see something like this, and it's not, this part of the code is not yet in the scope of the myVector class, the compiler needs a little help understanding that what that is a type. Otherwise, it's going to give you a syntax error. If I run this right now, it's going to give you a syntax error on this line because it can't recognize that this is a type, because that code right there that is highlighted is outside the scope of the class, right? Now, what's a little confusing about this, or I don't know if it's confusing, but it's just weird, is figuring out where the scope of the class starts. It turns out that the scope of the class starts here, where you put the name of the function in the scope of the class. Okay, so anything from here down to the closed curly brace, you wouldn't have to put size type in front, right? In fact, I don't even have to put myVector in front of value type, right? Because I'm already in the scope of the myVector class. So here's the rule. Sorry, I'm not sure if that made sense, but I think it'll help to see the rule. Outside of the scope of the class, add the keyword type name. Oops, type name before any use of one of the types defined in the class. Okay, so in our class, we have defined 2 types. We've defined size type and value type. If I use either of those types outside the scope of the class, I have to put the word type name in front of it. So it turns out that I'm using size type here, and it's not in the scope of the class, right? If I used size type sometime after this point in the code, then the compiler would know we were in the scope of the class. But because I haven't gotten to that point yet where I'm inside the scope of the class, I'm going to have to put the word type name in front of the type here. Okay. So I'm doing 2 things at once here, sort of. I'm trying to explain the rule, and I'm also trying to explain the reasoning behind the rule. If that's a little confusing, let me just focus on the rule itself, right? The rule itself is not all that hard. It's just when you see size type or value type, and it's outside the scope of the class, add the keyword type name. Turns out, at least in my experience, the only time I have ever seen this is when the type is a return type. That's what we have here, right? The size type is the return type of this size function. Okay, so looks like we've got it again here. And looks like we've got it again here. It's actually a little odd to have such a high percentage of my functions return a type that's defined in the class, but there you go. Any questions about that? Not sure if that feels hard. I don't think it'll be that hard once you sit down and start writing the code. Okay, that's step 4. Step 5 is don't compile implementation file separately. Okay, so that requires some explanation, right? Up until now, you may not have realized this. You mean throughout the whole lecture or just in step 4? Like step 4 is not going to affect the header file because in the header file, everything is already inside the scope of the class, right? Right, so the only thing, yeah, we changed in step 1, we added this to the top in front of the class declaration. And then in step 3, we had to replace int with t. Okay, so let me talk about compiling the implementation file separately. Up until now, up until we hit templates, what we've been doing, if we have a class, is we compile this client, and then completely separately from that, we compile the class implementation file. And then they get linked together by the compiler before, as it is creating the executable file. So say that again. So we compile. So if you've been using an IDE, right, you have the implementation file for the class in your project, and you also have the client in your project. You may also have the header file in your project, but it turns out that's not required. It doesn't have to be there because it's # included from the other files anyway. So what's going on, whether you realized it or not, when you choose go or start without debugging or whatever, is you're compiling the implementation file, and then as a completely separate task, you are compiling the client file. I shouldn't say you, right? The IDE is doing all of this. And then the IDE is linking those two together to create the final executable file. It turns out that won't work when we are using templates. And I'm going to explain why. It's not, if you don't get why, that's okay. But the reason is that the compiler can't compile a templated class until it knows what the type is going to be of the template. And it only knows that by first compiling the client. That makes sense? I think that's fairly straightforward. That should make sense. Anybody want me to say that again? Okay, so we can, okay, so I will repeat. Up until now, the process has been compile the client, compile the implementation file, and then link them together. The problem is that the compiler cannot compile the implementation file separately if it's a templated class, because it can't compile the class until it sees the client program to know what the type is that's inside those angle brackets. So instead of compiling it separately, what we have to do is essentially use # include to include that code so that from the compiler's perspective, it looks like it's all in one big file. Okay, so here's how we're going to do that. So again, to repeat again, we cannot compile the implementation file separately now So what we're going to do is we're going to use # includes to make it look to the compiler like it's all in one big file. Okay, so I have a 4-step process for making that actually happen. Delete # include of the header file from the implementation file. Okay. By the way, so the way that I'm saying this now is I'm talking about how to convert a regular not templated class into a templated class. You also need to understand enough about these steps to be able to recognize what's going on when you are presented with a templated class, right? So if I give you a class that's already templated, you need to know to make sure that your IDE is not trying to compile the implementation file separately. I think that is the point at which a lot of students forget. So anyway, delete the # included the header file from the implementation file. So going to find the implementation file, delete the # include of the header file. Okay, because it's all going to be one big file anyway. Step B. Add a # include of the implementation file at the bottom of the header file after the close of any namespace block. Okay, so basically what we're doing is instead of including the header file from the top of the implementation file, we are going to include the implementation file from the bottom of the header file. Okay, so that's basically how we are going to get it to look to the compiler like it's all one big file. It should make sense just looking at this file and nothing else, that what we have now from the perspective of the compiler is the class declaration and the class member functions are all going to be in one file now, right? Because I'm just including them from the bottom of the header file. Okay, step C seems to be the part that students most often skip or don't do. My guess is probably that, they don't understand exactly what it means, and so they just kind of pretend it's not there. So be super careful about this one. Remove the implementation file from your project. Okay, that if you've been understanding what I'm saying, that should make sense, right? If I leave the implementation file in my project, then it's the IDE is going to try to compile it separately. Not only that, but now that I have included the implementation file from the bottom of my header file, what's going to happen is the compiler is going to complain that you're trying to implement all of these functions twice. You see that error message a lot. If you get that, if you get any sort of an error message about functions being multiply defined or already defined or something like that, this is probably what you forgot. Yes, remove as in we would delete it from Xcode. There are different IDEs often have slightly different terminology for that. In Xcode, it's like delete, and then it gives you a choice of whether you want to delete it or just exclude it from the project, I think, something like that. And you would choose exclude it from the project, right? You don't want to actually delete the file. File's still going to be there, just not as part of your project. Okay, if there's no questions about C, step D, eliminate any using directives in the implementation file. Implementation file. Remove it from the source file's location in the Solution Explorer. Right. So in Visual Studio, you'd right click on it. I think there's an option that it says remove from project or something like that. That is correct, Trent. I'm not remove the file from the project. I'm not sure what file block means, but remove the file from the project and it's now only accessed through that include that we added. That is correct. Okay, so step D, to be honest, if you don't do this, your code will probably still work, but it's a matter of safety, okay? Now that we are including myvector.cpp from the header file, well, so we already knew that we shouldn't use a using directive in our header file, right? So what I'm saying now is myvector.cpp has essentially become part of the header file. We don't want any using directives in a header file because then some other client program that # includes it is going to be stuck with our using directive, and that may actually break it, right? So remove any using directives in the implementation file. And that, of course, means that if we have anything inside the implementation file that is using that namespace, we're going to have to indicate that directly. In our case, I actually don't think we have anything from the STD namespace in here anywhere. Typically, that would be something like having to do with iStream or OStream or cout or indel or something like that. And we aren't doing any input or output, so I don't think there's anything else to change here. Okay, so those are the 5 steps. Step 6, I'm not even going to talk about it. It's in the lesson, but as far as I know, I've been doing this for a while now, and no one has ever told me that they encountered needing to worry about step 6. So I would probably remove it from the lesson if I get a chance. So let's give this a whirl, see how we did. I mean, we did an awful lot of stuff, so I would not be surprised if we don't have everything perfect. Oh, so here's the other thing. This doesn't affect you if you're not using the command line, which I assume most of you are not using the command line, but if you are, or if you someday do that, the analogy to not having the implementation file in your project anymore is that at the command line, I'm not going to compile it. I'm just going to type to, I think what's the name of the file, the CPP. Before, last time I did this, if you look up here, I had to compile those 2 files separately, right? I had to compile the client and I also had to compile the implementation file. But now, because the implementation file is # included from the bottom of the header file, I don't have to compile it separately. Whoa, no compiler errors. I'm actually really skeptical about that. Well, look at that. Everything worked perfectly. Guess I should go to Vegas. Any questions about what is going on here? We'll go back and look at the client. I have demonstrated that we can have a my vector of ints and then also a my vector of strings in the same program, and everything works perfectly. Any questions about any of that? If not, I think I'm done talking about templates. There was something I was going to say and it flashed through my brain and it is gone now. So there's a const value we can find out. Let's look at the assignment at the lab for a second. On class. So first of all, let me just say that this may be something new to you. I'm not sure, but I'm kind of guessing it is. But it has nothing to do with templates, right? It's just something that is a gap that we hadn't ever actually gotten to. Yes, Kyle, that is correct. The file still needs to be in the same folder as the rest of the project, but not active in the IDE. So I guess typically the way you would do that is you would actually add it to the project the way you normally would, because then the IDE automatically stores it in the right place and then subsequently exclude it from the project. Okay, so lesson 21 is something that we aren't covering in this class. Someone asked why we are skipping lesson 21. And the way that I have written my lessons out, lesson 20 is about linked lists. Lesson 21 is actually about stacks, but we're not covering stacks in this class. And then actually we're not covering lesson 22 either. Originally we had planned to, but I canceled that. Okay, so looking at this line here, basically the way that constants in class declarations work is that you declare the constant inside the class declaration and you put the word static in front. But then you have to actually define the value outside of the class declaration. Okay, you're not allowed, except with, there are some exceptions, but generally speaking, you're not allowed to initialize a constant inside the class declaration. Okay, so what's going on in this line is this actually works because int is an exception, right? You're allowed to initialize a constant to an int inside the class declaration. But when I switched to when I switched to templated class, I don't know what's going to be here, so I can't do the assignment inside the class declaration. So I'm going to declare the constant inside the class declaration. And so it's just going to be exactly like that. Exactly, just uncomment it. So the point here, sorry, backing up a little bit, what this explains is that this is what's going to work for the non-templated class. When you switch to the making it work for a templated class, you're going to comment this out or delete it and uncomment this line. Okay, and those two lines are exactly the same, except that in this line, I don't actually give it a value, I just declare it. So this line down here is where I actually end up giving it the value. And I want you to figure out exactly how that's going to work. But I will just say, obviously, int isn't going to work here because it's not always going to be int. I think I'm just going to leave it at that because I want to leave something for you to be able to figure out. The goal is for the default value to be generic. Well, yes, right? I mean, it has to be. Okay. So the plan was to talk about exception handling now. We only have a couple minutes left. I think that what you're going to see in the lesson, I think it's going to be okay to just go from the lesson. I really cover a very small subset of exception handling, just enough so that you can do the basics and practice a little bit on this assignment. So I wouldn't expect that to be a problem. It's covered in the textbook also in quite a bit more detail. But in order to do the assignment, you just have to know the stuff from the lesson, which is really only like a couple of paragraphs. So I'm gonna leave that for you to read. If you really like seeing it in lecture form, you can take a look at the video, the optional video that's in Canvas from a previous semester. And so I think we're going to stop there. And on Monday, what I'm going to do is I'm going to start on linked lists because that's all we have left after templates. Lesson 19 has exception handling. So that's the same one with templates. All right, so if there are no other questions, I will see you next week.